Hello, my name is Ali Kararudi, and in this video I'll be talking to you about bubble sorts. Without any further ado, suppose list 0 all the way to n minus 1 is a list of n elements, indexed 0 to n minus 1. We want to rearrange, that is sort, the elements of list in increasing order. The bubble sort algorithm works as follows. In a series of n-1 iterations, the successive elements list index and list index plus 1 of the list are compared. If list index is greater than list index plus 1, then the element list index and list index plus 1 are swapped. Okay, let's see how does this work. Consider this unsorted list that we have on the left. So the list is now sorted as 10, 7, 19, 5, and 16. So what we do is we start from the top. We compare two items. So we have 10 and 7, right? So if we have 10 and 7, what is going on is 10 is greater than 7. So what we need to do is we need to swap 10 and 7. Look at this part of the image. Now 10 and 7 are swapped, and therefore 7 is on the top. So on the next iteration, we compare the next two items, which are 10 and 19. In this case, 10 is less than 19. So what we need to do is we need to keep them the way they are. No swap is needed. So if we move forward and compare next two elements, now we have 19 and 5. If we compare these, we notice that 5 is less than 19. Therefore, we need to do a swap. So the new order is going to be 5, 19. And then we move to the next iteration, which is comparison of the two items. So now 19 and 16 are being comparison, right? When 19 and 16 are comparison, we notice 16 is less than 19, so we need to swap. Therefore, we swap them, and now 16 is on top and 19 is on the bottom. If you notice through these steps, now we have 19 on the bottom of the list, which is the largest number in the list, right? So what we do is now we iterate the same functionality, but this time over this part of the list, the unsorted list that we had. So we compare 7 and 10, no move needed. We compare 10 and 5, a swap needed. We compare 10 and 16, no swap needed. And now we have 19 and 16 at their correct place, and the rest of the list needs to be checked. Now we go back. We start with 7 and 5 in the next iteration, and if you notice now 7 and 5 need to swap, so we swap them. We are here, 5 and 7 are swapped. Now we compare 7 and 10. No swap is needed, and at this point we have 19, 16, and 10 sorted, and the last thing we need to do is to check 5 and 7. So now our unsorted list is only this part on the top. We do a comparison, no swap needed. Now we have 5, 7, 10, 16, 19, and as you can see, we just sorted the entire list in 1, 2, 3, and 4 iterations. Here is the implementation of bubble sort in C++. So we have a void function here, which is the bubble sort function that receives the list and receives the integer length. So what we do is we come up here, the outermost loop that we create has an iteration, starts from 1, and as long as iteration is less than the size of our list, we go ahead and iterate. The inner loop says we have an index. This is going to be the index of the list, right? We start from 0, and as long as index is less than length, what we do is we do index plus plus, which is the iteration, right? So remember, this is length minus iteration because of the fact that each time that we go through one iteration, we don't need to touch the element that is already at the right sort place again. And then the comparison is happening over here. So if the list at this specific index that you're looking at is greater than list index plus 1, then as you can see, a swap happens. Remember, we always need a temporary value whenever we need to do a swap to keep the value over there, avoiding losing value due to the overwrite. So pretty simple. As you see, that's the same implementation of the idea we talked about. Okay, now let's talk about the analysis of the bubble sorts. We have done many analysis before, like the last analysis we did in our videos was about search algorithms. In the case of search algorithms, our only concern was with the number of key item comparisons. A sorting algorithm makes key comparisons and also moves the data. Therefore, in analyzing the sorting algorithm, we look at the number of key comparisons as well as the number of data movements. Suppose a list L of length n is to be sorted using bubble sort. Consider the function bubble sort as given in this video. This function consists nested for loops. Because L is of length n, the outer loop executes n-1 times. For each iteration of the outer loop, the inner loop executes a certain number of times. Let us consider the first iteration of the outer loop. During the first iteration of the outer loop, the number of iterations of the inner loop is going to be n-1. So there are n-1 comparisons. Similarly, during the second iteration of the outer loop, the number of iterations of the inner loop is n-2 and so on. Thus, the total number of comparisons is going to be n-1 plus n-2 plus so and so plus 2 plus 1, which it can simply be transferred to n times n-1 divided by 2, which I can write it as big O of n2. In the worst case, the body of the if statement always executes. So in the worst case, we have 3 times n2 minus n divided by 2, which is still as a factor of n2. If the list is already sorted, which is the best case, the number of assignments is 0. It can be shown that on average, bubble sort makes n times n-1 divided by 4 item assignments. However, the number of comparisons for the bubble sort as given in this video is always n times n-1 divided by 2, which gives us the big O factor of n2. So as you can see, to sort a list of size 1000, bubble sort makes up to 500,000 key comparisons and about 250,000 item assignments. This is a very big number. So this sort algorithm is not really the best algorithm for sorting. So this concludes this video. For implementation, please look at the implementation of bubble sort video.